Hello mathematicians, hope in this video you can say I can factor difference of squares. We're going to look at a few different examples in this video here. So we're given x squared minus 25. And in this problem we will see that there's only two terms. So our b is equal to 0 if we were to think of a trinomial as ax squared plus bx plus c. So our b would be equal to 0. So if we were to try to factor this using our kind of traditional factoring methods, well, we look for factors of negative 25 that add up to 0. So we go negative 25, and obviously we have 1 and 25. But let's go, so we go 5 and 5. And we know one of them has to be negative, because this is negative 25. We know that negative 5 plus 5 is equal to 0. So this would factor out to x minus 5 and x plus 5. And that's all fine and dandy, and we can use that method. But one thing that we'll notice about this is that both of these two terms have perfect squares. They have factors that are perfect squares. So, and this problem is fairly easy because in this situation our a was equal to 1. But we're going to see that there's a much easier way of doing this if we see that both of these two terms have perfect squares. So let's just table this for a second, and we're gonna come back to it in a minute. So over here we're given g plus h and g minus h. So if we were to FOIL this out, so we have g times g, well, that would give us g squared. And then we could go g times negative h, which give us minus gh. And then h times g, that'd be hg or gh, so plus gh. And we go h times negative h would give us minus h squared. And we'll notice that in this polynomial here now, these middle two terms, negative gh plus gh, these two would cancel each other out. So what we'd be left with then would be g squared minus h squared. So if we were to compare that to what we start out with, well, that gives us that this right here. So if we take a look at this, well, we'd see that this right here, if we were to factor it out, or undo the foiling, would factor into g plus h times g minus h. So now if we were to take kind of this idea, move it back over here, well, we could see that this expression right here could be rewritten as x squared minus 5 squared. So in this problem, so kind of linking it back, I'm going to put some parentheses on here just to make this explicitly clear. We could rewrite this right here as, well, we see that our g is our x and our h is our 5. So we could rewrite this using kind of this formula, if you say, as x plus 5 and x minus 5, without really needing to even look for factors of negative 25. And this would be maybe an easier method of doing that. And you might say, well, that really wasn't too hard up here, so I'm just going to stick with this. But now let's give you another problem, which might be a little bit trickier just to factor by just looking for your factors of this term here. So we're given 4x squared minus 64. Now in this problem, our a is not equal to 1, which makes this possibly a little bit trickier to factor out. But let's just think about this. Well, in this problem, both of these two terms have perfect squares. So if we were to undo that, and if we were trying to find the square root of both of these, well, we could rewrite this as 2x, that whole term, squared minus 8 squared. And now we could plug these values into this formula, if you want to call it that, so we would get 2x would be our g, and our h would be 8. So 2x plus 8 times 2x minus 8. So this would be the factor version of this expression right here. And it's a fairly straightforward process if we can see that both of these two terms have perfect squares, and figure out what those perfect squares are and plug them into this formula. So that's it for a video. After watching this and getting a little practice, you can say I can factor difference of squares.